Next, I'd like to introduce Timothy Guo. Timothy Guo is the BLUEsat team satellite CTO for the past year. He bears the goal to launch a CubeSat developed by students. The team spans across multiple disciplines and levels of experience. They are a volunteer student organization within UNSW, and they have been critical in helping out AXA with some of the ground station works in the early operations of the CubeSat of UNSW EC0. So, Tim, the stage is all yours. Go ahead.
Okay, cool. Hi everyone, I'm Tim, representing student group here at UNSW called BLUEsat. So we're a society with a mission to give students real-world experience and to promote this social interest in space. So this isn't so much about a technical presentation like the previous ones. This is a bit more of an insight into the functions of our group, the movement of advocating this interest among university undergraduates. So discussing the journey that undergraduate students take, it's about sort of the opportunities that we and other space organizations like AXA provide, and the questions that we're trying to encourage them to ask. And many of these questions, they apply not just to developing student societies. This sort of extends on into the professional environment as well. There's like questions like, what might be the next innovative CubeSat design be, and how do we excite people about off-Earth mining? Like, it's questions like these where we really want students to start thinking about. And that's why there's an emphasis on student societies as well, because this is the next generation of bright ideas and leaders. So we want to provide the right environment for the right leaders to evolve. And that also depends on the leaders that we have today. So that's just a team up there. It's a pretty medium group, big mix of personalities. We're all in our groups, different projects, all very different. We've got different levels of experience, different stages through our degrees, different backgrounds racially, but also like different backgrounds in like disciplines. It's kind of like a company because everybody's sort of different. It's a mix, but we're all aiming for the same goal essentially, and that's our society. So there's 3 stages to the society. It's about guiding and influencing the next generation, giving them tools to build the answers to these questions, and then pretty much providing a platform for them to share these answers. We let them learn through the projects that we give them. This is through the CubeSat mission, this is through the balloon, this is through off-world robotics and the ground station. Then we give them group dynamics to grow into leaders, to learn skills, face challenges, overcome these challenges. And then events like these, we start networking. We push the boundaries of the network beyond just our society, but to the greater community of the space community. So to sort of put it into a bit more of a relatable perspective, and essentially what we're looking at is how do we move from this to this? I've got permission, so.
Do you want to?
So, yeah, moving on. So,
You asked me for a better picture.
I was thinking of it, but I was like thinking, should I even ask? I'll just go for a good surprise. So I'll just quickly go over some of the projects that we've got for students. The ground station, it was formed from an opportunity provided by AXA. AXA's EC0 that allowed us to build up the ground station. And as we know, the EC0 is still flying high above, so that's still progressing. The off-world robotics, they've actually progressed very far. They've placed 9th in the European Rover Challenge in previous years. They've just made the next model and they're going to compete again, once again later this year. The balloon you've heard a little bit about already. They're essentially the high altitude balloons with stabilization mechanism and sensory instruments, and working in collaboration with the University of Pisa. So, CubeSat. So CubeSat, we're looking to develop a biological payload to send into space. So this is with the aim to improve the ability to perform agriculture in a space environment using cyanobacteria. You can sort of see it's a very diverse span of projects because we have a very broad range of interests, and we even had biology students because we want to investigate the possibility of agriculture in space. The list has grown as well. We started off with just one project, and that was the satellite project. And as more opportunities were opened up, we grew our spectrum and grew the members as well. So the next part is growth. This is sort of the cycle of where we try and make the student become the teacher, where you sort of lose members and you're gaining new members, and people graduate, and the cycle sort of continues on. And then somewhere along the food chain you have AXA and UNSW sort of providing us with help. So this knowledge is passed down, and something really great that we see is that there's a production of leaders. There's the opportunity for members to fill the shoes of the graduates, and this creates a culture for leaders to come about. And this challenge of stepping up, it's not easy, and often the team success is like dictated by the leader. And we know how important it is to have this growth in leadership, because we can see the impact of the people today that have talked and how much of an influence it has on the community. And last of all, it's about connection. So BLUEsat exists to connect students with the right people. We want to connect. We want to talk to the right people. We want to see what the next step here from undergraduates is. We want to make this path after graduation, so that not only do we find the right job, but we've already been talking and working with the company before we actually graduate. An interesting figure about our society is that a bit over 10% of our society are actually entrepreneurs, with some of our members actually presenting tomorrow. You'll hear about them. So events like these workshops, they're really great for us to build these connections. It's massive thank you to AXA for actually organise these and all the other events they actually organise. It's not easy. We're actually trying to do our own event ourselves later on in August, a showcase. And it's an opportunity for anybody here to actually come along and attend, actually see stuff where we can showcase. Yeah, so that's about it. I'll probably close my presentation here. It's been a little bit tough for time. If you want to chat at the end of it, talk to me. We're sort of huddled up in the back area over there. You can sort of like see if we're waiting and stuff. Feel free to talk to us. There's some details on there. And yeah, thank you so much.
We've got time for one question.
Oh, yeah.
Do you have any questions?
Can I ask
Perfect.
one? You mentioned for the agricultural experiment, what you refer to in terms of the agriculture in the satellite?
Beg your pardon?
You mentioned the biological or agricultural
Yeah.
experiment or
Yeah.
something with the system.
Mm-hmm.
What do you mean?
So it's essentially looking at the effects of a space environment on cyanobacteria. So we're looking at how flexible it is that we can actually cultivate these bacteria in space, and then if these bacteria is actually viable in the conditions of space. So we're testing about all those, but there's also this secondary mission of actually sending CubeSat into space, because that in itself is a challenge.
What is the range of the altitude? Because predominantly, I guess in that range, with nano sunlight, maybe not terribly interest. If you're lower that level, there might be a more interest. Do I understand correctly?
What do you, could I ask what do you mean by of interest?
No question. The satellite orbit, how high the orbit will be?
We're looking at just the ordinary low Earth.
300,
400,
500.
340? About 340 currently.
So the main thing is microgravity, I think, is the key point of the experiment. Rather than
something lower than the ISS that would
yeah.
Bacteria tend to behave quite differently in microgravity.
That's right. Yes, that's quite differently. Yes.
Thank you.
Well, still not said yet. Thank you, Timothy.